This slide I open with at most of the conferences that I go to. This is a very critical issue. All of the ships that we're designing today will be operating in a net zero emissions world by the end of their operational life. We are very, very far away from having zero emissions vessels that are going to be operating at the end of their life in that situation. So every single ton of CO2 that we emit after 2030, we're going to be paying a very, very high price for. And what I'm going to show you today is some potential options around wind propulsion that can get us at least some of the way down that pathway. We've already heard quite a few of these words being used. These are the words that definitely signify where we are in the industry. The uncertainty, transition, volatility, I mean, we really don't have that crystal ball. And I think we had that very clearly pointed out over the last couple of presentations. I was actually one of the expert reviewers on the IPCC 1.5 degree report that came out a couple of weeks ago, asking for very, very dramatic reductions in CO2. Now, to the IMO's credit, we've had the initial strategy, which there was a lot of pressure to get the at least 50% in there by 2050. That's a huge nut to crack. Hopefully, by showing you about wind propulsion, I'll show you a way to make that nut just a little bit easier to crack going forward. But a lot of you are thinking, wind, sails, maybe a kite, something like that. There are a lot of options, and this slide doesn't cover, these are not all vessels in the water, some of these are concept vessels, but I'm going to touch on what wind propulsion actually means in the market today. So IWSA is the International Windship Association. We were actually set up in 2014, so we're very young, just like me. No, thank you. But we have over 35 technology providers now. We're working with some of the largest shipping companies in the world, which you will see in a moment. Now, just very quickly, everybody asked me, so wind propulsion. I'll get onto the technologies in a minute, but let's get down to the nuts and bolts. What kind of market are we looking at? This was a market estimation made before the sulfur cap was agreed, before actually 18 months ago, the IMO, everybody in the IMO is saying, we are not going to put a numerical target on CO2 in the shipping industry ever. 18 months later, what do we have? We have the initial strategy with exactly that. So things are moving, and for the IMO, that is extraordinary, extraordinarily fast. But I just want to point out, rather than going through all of the details here, this study on the left, on the right, Norwegian University of Science and Technology, very clearly said, actually, the technology basket isn't really the problem. We've got the technologies, we've got alternative fuels, scaling them, replicating those across the market. Different segments have different challenges and barriers, but actually, that isn't the problem, it's the facilitation. And we've just heard from Hamburg School of Business Administration, Professor Orestes, talking about, so we've got all these ideas, we've got LPG, we've got LNG, we've got all of these other alternative fuels. How do we get these scaled, and how do we get them onto ships? This was a survey done, I think it was last year, for LR. 80% of the ship owners and experts in the field agreed that zero-emission vessels are needed. I was quite shocked by this. What do the other 20% think we're going to be doing? I'm not sure. But anyway, some very interesting things. I'm just going to touch on the carbon price, which has been highlighted a couple of times. I think the Daily Telegraph in the UK, as you might work out, I'm from the UK, they just called carbon the best commodity on the market at the moment to invest in. It's increased from €7 per tonne to €20 per tonne in 12 months. That's over €60 per tonne of fuel. One German bank is actually estimating it could go up to €100 per tonne of CO2 by the end of 2020. Now, that's at the very extreme end. Most forecasters are saying 40 to 50 tons. That's 150 tons, $150 or euros per ton of fuel, on top of the sulfur cap, which we're expecting probably to add $100 to $150 per ton, et cetera, et cetera. So it's a very serious situation. And this was a conference we did last year with some very big players, and this was reiterated. The technology basket actually wasn't the big issue. Coming on to wind, which I'm here to talk about. There are actually 7 technology areas. The main ones are the kites, which I think if anybody's was around in the shipping industry about 10 years ago, every single presentation, regardless of what it was on, had a kite on one of the slides. Interestingly, actually, Airbus have just invested, I think, up to 7 million euros in a project to develop kite propulsion again. So we're looking at new entrants coming in. Google recently put out a patent for an energy kite as well for ships. So we've got some quite big names coming in. Rotors, I'm actually going to focus on rotors in a moment. That's actually breaking into the market right now, and I will point that out in a moment. Those are called Flettner Rotors, for those of you who haven't heard of it. Been all over the news recently. Hard sail does pretty much what it says on the tin. If you've watched the America's Cup or the Volvo race, you know, the America's Cup, you know, these things go 2 times the speed of the wind, which to me, being a non-engineer, that's magic. But these are now being engineered into commercial use. Okay, and we actually have quite a few of our members that are working on those. Obviously, soft sail and dyno rigs. There's just been a recent announcement the last few days that a Russian billionaire is actually looking to invest in 15 vessels using this dyno rig system. Let's hope that happens. The suction wing, which is it uses the same principle as a rotor, which is the Magnus effect, a little bit like an aircraft wing. There's a differential on the pressure, the air pressure, which creates suction forward. This was actually designed, or the original design was by Jacques Cousteau. So for any of the younger members of the audience, maybe who the hell is he? I remember him very well. But that was tested around the world on his research yachts. Turbines, obviously, kites we just talked about. And the final one is hull form. And this is quite an interesting one from Norway, actually, this project, where the actual hull of the vessel is like an aerofoil itself. And this is interesting because it can bleed into design in all various different hulls. If we can get 5–10% lift and thrust from the actual hull itself, that's a really innovative thing. This is supported by the Norwegian government, and they're looking at 60–70% potential of fuel savings, which is unbelievable. It's still in R&D, but we will be watching that space very closely. I'm not going to go through this, but I'm sure these presentations will be available to you. Where are we in the commercial application or the development of these? 2018, we're seeing the vast majority of these are now coming out of R&D onto demonstrator vessels. And I will just highlight that with the Flettner Rotors, which are actually market ready. You can go out and actually buy these if you wish. That's just an outline of where our members are. There's some quite big names. STX France, which has just changed its name to Atlantique Chantillière, which is a much more beautiful name. But big shipbuilder. They've come on as a full member. They've just actually released a series of cruise vessels which are 70% wind-powered, but they're on the research and a little bit smaller 200, 300 passenger cruise vessels, but beautiful designs. Now, the Flettner Rotors, again, I'm not going to go through this slide in detail, but this just gives you an idea of the progression. What I want to come on to is 2018, and I'm just going to show you the 4 vessels this year that have actually been installed, either they're all retrofit actually, one new build as well. But This was the one that broke the news about 2 months ago. It's the Maersk Pelican. She's a 109,000 deadweight ton LR2 tanker. She's had 2 Flettner rotors installed. These are 30 meter by 5 meter diameter. Now, Flettner rotor, basically it rotates, and there's a small electric motor. That rotation, you have a difference in the air pressure on both sides as the wind hits that, and that creates thrust forward. These were developed about 100 years ago, actually. So there's a few old grainy pictures of Flettner rotors. The Wall Street crash basically killed that when the fuel prices went down as well. But Maersk has stepped up and said, we want to test these on our tankers. And you're looking between 7 to 10% savings. Now, that is a substantial amount when you're looking at the amount of fuel that these things burn. Maersk is going for distillates mainly. That's my understanding. So they're not going down the scrubber line, they're going mainly down the distillate line. And they're talking about a $3 billion increase in their fuel bill. 7 to 10% of that is not small change. So I think we can see that that's developing. And this was fitted in Rotterdam. She's in operation now. It's only been about 8 weeks. We're waiting for the statistics to come in from that. A second one, it's a little bit of a grainy picture. I didn't realize that when I put this. This is the MV Avros. It's a Greek-owned company, Blue Planet Shipping. The company that's actually produced the Flettner rotors is based in London, called Anemoy. And this is a 64,000 deadweight ton bulker. Interesting, these Flettner rotors, a lot of people look at that picture and go, yeah, but when you're loading and offloading, that's a real pain in the ass to have those rotors there. These are actually on movable bases. So you can move them out. She's a geared vessel, so obviously that's an important innovation. She's been operational since late 2017. I think she's in the Pacific at the moment. She's on various routes in the Indian Ocean and the Pacific. The Viking Grace, which is an LNG-powered ferry cruise vessel, she was fitted, again, I think in April, with 1 Flettner rotor. Actually, Viking Lines have also ordered a new build with 2 Flettner rotors. That's being, I think the launch date's 2020 in a Chinese yard. And finally, one very close to home, up in Emden, or in Lear. This is the Fem Pollux, and that's called the Eco Flettner, and that was installed in April or May, and again, they're just processing the statistics on this. This is a test rig. It's obviously quite large for that small vessel. It's an EU-funded project called Marico, or Mary Green. Some of you may be aware of that, based up at Hochschule Emden Lear. And next week, which I'll get onto a little bit later, if you're interested, they'll be coming to Hamburg to talk about this. Now, just a couple of other case studies, because I'm a little conscious of the time. I'm not going to go through all these statistics. I have many of these slides with case studies. What I'm trying to highlight here is some of the big players who are taking a very serious look at wind. And this includes MOL, MYK lines over in Japan. And I visited the test rig. That's a land-based test rig on the right side. All of the land-based testing is finished. They're going for an installation probably the end of next year, just because of the dry dock cycle for the vessel that they've selected. But very interesting project, and hopefully we'll see the ones with the larger number of rigs there. And they're collapsible. Yep, so they concertina down. This is another case study. Just very interestingly, we've had a couple of these recently that are looking at, is it possible to get a carbon neutral vessel today? And obviously with biofuels, for example, which are limited at the moment, there is potential. If you're looking at 20, 30% reduction in your fuel use because you're using wind, potentially up to 50% on the same operational profiles. But we like to say, you know, let's talk 30%. Then with other operational changes, slow steaming, maybe heat recapture technologies, and some alternative fuels, you're getting close to a carbon neutral or 100% renewable energy option in shipping. Don't believe me, believe my members. So very quickly, this is the last point I just want to make, is we're actually developing wind propulsion hubs now. So kind of clusters to actually share best practice, try to avoid worst practice, and reduce costs. One is already developed in Nantes, and that's attracted over 60 companies clustering together, engineering, shipbuilding, projects, etc. We are going to be developing one in North Europe and the Baltic, and that's part of the reason why I'm here over the next 2 weeks. We're having stakeholders meetings, preliminary ones, probably based on the Rotterdam-Hamburg axis, including some of the Scandinavian countries. I won't go through that one. And finally, we're also looking wider than this. I'm actually one of the board members of the World Wind Energy Association, and we are the voice of wind energy, if you like. They do onshore, offshore wind, and we're doing wind on vessels. And what we're looking at is the combination here of renewable energy. A lot of the offshore wind actually produces a hell of a lot of energy that they can't do anything with. So converting that power to liquid, power to gas, and direct wind propulsion. We're starting to look at what I think I called in the last press release a perfect storm coming together. And very finally, I'm absolutely terrible bit of advertising, but I'm going to be here next week. We're doing a couple of seminars, kindly hosted by the Hamburg School of Business Administration. If you want to hear more than 12 minutes of me talking, you're more than welcome. Okay, thank you very much.